right, we're going to do one more in class. All right, so rational functions and their graphs. All right, so this one is, I think, on the back side of your notes. Wait, no, not this one. It's 2x squared. Nope, not this one. It's the next one I'm going to do in class. So this one's not in your notes, so sit back, relax, and watch me do some graphing. All right, so of course we need to factor first. I have the factoring over there. I'm looking at that. I didn't put it at the bottom like I did on the last one. I put it up nice and high so I would notice it right away. All right, so 2x squared plus 5x minus 3 is going to factor. Right? 2 times negative 3 is negative 6. Multiplies to give us negative 6, adds to give us positive 5 would be positive 6 and negative 1. And there you can see all the steps for that. All right, so we can see we have no repeating factors. 2x minus 1, x plus 3 does not match x plus 1, so there are no holes. We have one vertical asymptote. All right, we said x plus 1 equal to 0, x equals negative 1 is the vertical asymptote. Again, you have a choice on this one, whether you use synthetic or long division. It makes no difference to me so long as it's appropriate for the problem. All right, so let us, we're going to do both ways. Let us first use long division. I ask myself, what do I have to multiply x by, that first term, to get 2x squared? Well, I'd have to multiply it by 2x, right? So x goes into 2x squared 2x times. 2x times x gives us 2x squared. Okay? And then 2x times 1 is 2x. And we subtract, which means we have to add the opposite. All right, so 2x squared minus 2x squared is 0. 5x minus 2x is 3x. And we bring down the next term. And we ask ourselves, what would I have to multiply x by to get 3x? And we'd have to multiply it by 3. So x goes into 3x 3 times. So 3 times x is 3x. 3 times 1 is 3. And we subtract, which means to add the opposite. So 3x minus 3x, there's a negative there, I got lost, there we go. 3x minus 3x is 0. 3 minus 3 is negative 6. If you get 0, and you can see, and you factor correctly, and you can see they don't match, you've made a division error because you're not going to get 0 unless the factor appears in both the numerator and denominator, and it's not going to. Right? Otherwise, we'd cancel it. So we don't care about the remainder. We only care about the part that went in evenly. Right? So our equation for our slant asymptote, actually I'll write it over here, and we'll do it with synthetic then, is y equals 2x plus 3. That is our slant asymptote. Right? So let us get rid of that, maybe. And let's use synthetic division. Right? So we set x plus 1 equal to 0. Got to do that. Don't take 1 because you're not really dividing by, you're divided by x plus 1, which means that x is negative 1, right? So when we use synthetic division, right, we want the actual x value, not the factor. Factor is long division. The actual answer is synthetic. So we are not missing any terms. Otherwise, I would have had a 0 something on the long division there. So we write our coefficients, 2, 5, and negative 3. We bring down the 2. 2 times negative 1 is negative 2. Add, we get 3. 3 times negative 1 is negative 3. Add, we get negative 6. And you can see they match. This is the remainder. We don't care about it. This is the constant. This is the x. We only care about those two. So y equals 2x plus 3 is our slant asymptote. We have 2 x-intercepts. We set those factors in the numerator equal to 0. So we have an x-intercept at negative 3 and 1/2. That is 2 of our points. We could also find our y-intercept. Our y-intercept is pretty darn pretty. Let's find our y-intercept. Let's do it right here. So f of 0 is, I bet you can see it, what the y-intercept is going to be. 2 times 0 squared plus 5 times 0 minus 3. And 0 plus 1, the only thing that's going to be left is the negative 3 and the 1. So that is negative 3. So we have a y-intercept at 0, -3. That's 4 points. We only have 3 points, and we only have one vertical asymptote. So that may be almost enough points, right? Let's find it and see if it is. So you notice the only thing different here is the slant asymptote and the shape, right? The shape and finding a slant asymptote, but it's not really a lot different. I already graphed my vertical asymptote. I think you can see it. I don't know, maybe I should have chosen a better color. I don't know. I could maybe choose another color if you so want me to make it a little bit darker. Maybe that color would be better. Isn't that pretty? All right, we'll make this one pretty too, and the same. Oops, I just want to change the color. Come on. And boop. So maybe you can see that a little bit better. All right, so there's our vertical asymptote right here at x equals -1. And there's our slant asymptote at y equals 2x plus 3. And you know how to graph these, right? Because all you have to, it's just a line, a linear function. You can graph that, no problem. Easy cheesy lemon squeezy. So we just need some points here. All right, so I don't remember what our x-intercepts were. I forgot already. So -3, 1/2, and -3 for the y as well. So we want to include those values because, well, we found them. So -3, 0, and we have no, it was positive 1/2. Wasn't it? Yes, it was. Positive 1/2, 0. And then we have 0, -3. So we have 1 to the left and 2 to the right. Let's graph those points, and then we're going to find a few more. So we have -3, 0. And that's it. That's certainly not enough to graph. And I don't want you just following it along. It needs to reasonably approximate it by finding the values. So let's find 2 more values. All right. So we might on these ones want to find 6 values. Probably back here I should have. Oh, I skipped one. Oh, that's okay. The one that's in your notes I skipped. That's all right. We'll do that one in class. Probably should have found one more here. It was just so close to the asymptotes that there wasn't really much more room for that thing to go to. But we probably should find 6 points, 3 on each side. And that's what we'll do on this one. We'll make sure this one's graphed. So I actually skipped the one that's in your notes and did this one. So that's okay. Oops. And let's go here. All right. So let's plug in -2 and -4 real quick. So if we have -2, we'd have 2 times -2 squared plus 5 times -2 minus 3, all divided by -2 plus 1. That's going to give us -2 squared is 4. 4 times 2 is 8. 8 minus 10 is going to be -2. -2 minus 3 is -5. And then -2 plus 1 is -1. So that is 5. So we have the point -2, 1, 2, 3, 4, 5. All right. Let's get one more, because notice I'm not quite as close. Let's get one more to make sure that our shape is pretty good. So let's take -4, I guess. All right. So we'll take -4. All right, so if we do that, we've got 2 times -4 squared plus 5 times -4 minus 3, all divided by, come on, -4 plus 1. That's going to give us 16 times 2 is 32. Minus 20 is going to be 12. 12 minus 3 is 9. And another nice one. -4 plus 1 is -3. That's going to be -3. So we have the point -4, -3. That's plenty. We can really see how that is going to go, right? So we're going to not cross the slant and not cross the vertical and go through the points, right? We want to be as accurate as we can be. On the other side, we have 0, -3. We have a 1/2 0. Okay. Let's get one more point Let's plug in a value that's a little bit larger. Let's plug in a 4 to help give us our shape here. So I wish I had just a little bit more space. Maybe I can move this up. Sometimes, no, or I can just move that bar down. It seems like it's harder for me to grab things when I'm recording. All right, let's move everybody up just a little bit. Here, that's perfect. Here, we'll squeeze it in right here. Nobody says he has to be on the bottom. All right, so I said I wanted to use 4. Let's use 4. So we have 2 times 4 squared plus 5 times 4 minus 3 divided by 4 plus 1. So that's going to be 16 times 2 is 32. And then plus 20 is going to give us 52 minus 3 is going to give us 49, right? 52 minus 3, 49. Not as going to be as pretty. And then 4 plus 1 is 5. Well, it's kind of not that bad because if it was 50 instead of 49, that would be 10. So that really gives us a good shape, and we can see how fast this is growing. Right? And it really is hugging that asymptote. So I might not have drawn it as close to the asymptote if I didn't use that point. All right, so again, we're going to go through those points, not cross those 2 asymptotes. All right, domain, just take out that vertical asymptote, negative infinity, negative 1, and negative 1 to infinity. And notice that range is negative infinity, to infinity. Function is reaching nice and high, so negative infinity to infinity. Now you may wonder if every single one of these graphs with a slant asymptote is going to look like this. And I'm going to tell you the answer is no. We're going to see a different graph in your notes. So on Monday in class, we'll see another graph, and it will not have this shape. All right? It will look different. All right, so bye for now.